This is page 3 of the communication notes, and it's section 3, and I'm going to cover something called double buffering. And for this we're going to use two buffers, and the idea there is that the producer can fill one buffer while the consumer is emptying the other, and then they can swap. And it's used in graphics to avoid the tearing problem. Let me just show you what that looks like. So this is from the Ubuntu Mate website, and there's this image here. Let's make it a little bigger, where you can see that there's 2 points in the screen where the image doesn't line up, and what's happened is it's refreshing the image in the buffer at the same time that it's drawing it to the screen. Really, you want the refresh in the buffer to happen and then the draw to the screen to happen, so they're out of sync. So if you use two buffers, you can be refreshing one while the other is being used to draw. So the refresh part would be the producer putting new content in a buffer, and then the draw part would be the consumer using the other buffer. Okay, so it fixes the graphics tearing problem. Okay, so here's the semaphores that we're going to use. We will use B0 empty, and that will be initialized to 1 because both buffers start empty, and B0 full will start out 0, and B1 for the other buffer empty will also be 1 because it starts empty, and B1 full will start at 0. So the consumer is going to be waiting on the full semaphore, the producer is going to be waiting on the empty semaphore. We're going to sketch this out now, the flow of what happens, and we're going to need 5 columns. The first 2 columns can be slightly wider, but this is going to need to squeeze this in a little bit. Gonna have to cram the consumer text in a little tighter. Okay, so we've got B0 empty, which will have an initial value of 1, B0 full, initial value of 0, B1 empty, B1 full, same initial values, 1 and 0, and the last column we'll fill in later. So that's our starting condition, and let's assume that the producer and the consumer can execute in parallel. So they need to use the buffers in the same order for this to work, so they're going to start with B0. So the producer will wait on B0 empty, and that's going to cause B0 empty to decrement to 0, but the producer doesn't block. So then it will go on and it will produce data, it will fill B0, and then it will signal B0 full, and that is one buffer done. So when it signals B0 full, that goes up to 1 here. Let's look at the consumer now. So the producer is going to wait on B0 full, and B0 full is 0 there, so it's going to block. So it's going to block, and then after B0 full is incremented by the signal from the producer, it will unblock. And I'm going to show it on separate lines. Really it would happen at the same time, but when it unblocks, B0 full is down to 0. Okay, so now it's got a buffer that it can work with, so it can consume the data in B0, and then it will signal that it's empty buffer 0. So B0 empty, that changes to 1. I'm not going to do the dashes here, they kind of obscure the zeros and the ones a bit. So it's finished with buffer 0 now, and it's ready to move on to buffer 1. Let's go back to the producer first. So the producer, after filling buffer 0 will have moved on to buffer 1. So we'll wait for B1 empty, and so that will go down to 0 here, and then it will fill buffer 1, so produce, and then it will signal that buffer 1 is full. Okay, and let's do one more iteration of each just to show how this can keep going along here. So the producer will now go back to buffer 0, so we'll wait buffer 0 empty, which conveniently was just signaled, so it won't block. It will fill buffer 0, and then it will signal buffer 0 full. Okay, and then it will move on to buffer 1 and back to buffer 0 again. The consumer, after consuming buffer 0, will move on to buffer 1. So we'll wait to be sure that B1 is full. So B1 full will decrement. It will not block this time. It will consume the data in buffer 1, and then it will signal that buffer 1 is empty. And so on. So what we can do now is we can actually combine the empty semaphores and the full semaphores into one semaphore each, and this will allow us to move on to a more general solution. So let's just look at the sum of these semaphores. So we've got the empty semaphores and the full semaphores, and the empty semaphores start at 0, and the empty semaphores start with a total of 2 and full with 0. And after this line, on the first line, empty gets decremented by 1, and then moving down, the full gets incremented by 1, and then empty gets decremented to 0 here, and full gets decremented to 0. And then they both go up to 1 here, both go back down to 0 here, and both go back up to 1 here. Now there's a total of 2 buffers, and so a buffer is either sitting empty, ready to be filled, or sitting full, ready to be emptied, or a producer or consumer currently have that buffer. So when you see the total on the line, for example, on the first line here, the sum of these two semaphores is 1, but the producer is now holding 1 buffer, so your total buffers in the system is always constant at 2. So the idea is to combine the empty semaphores, and in this case we're going to have a value of 2, and we'll combine the full semaphores, and they'll have an initial value of 0.